Mars has captured our imagination for millennia with its distinct, rusty light. Ancient civilizations saw it as a god of war. We see it as a destination with its own history. Mars is a terrestrial planet, much like Earth. Studying Mars is like looking at a sibling of Earth, one that followed a different path. The idea of setting foot on another planet is one of the grandest adventures we can conceive. We send our robotic emissaries to be our eyes on its alien surface, venturing into the unknown on our behalf. Through them, we are beginning to unravel the secrets of the red planet. To truly understand Mars, we had to go there. Not in person, not yet, but through the most sophisticated explorers we have ever built. This is the story of two of those explorers, two remarkable robotic geologists that have revolutionized our view of the red planet. They are the twin spirits of discovery, named Curiosity and Perseverance. These rovers are more than just machines. They are mobile laboratories, marvels of engineering designed to survive and operate in one of the most hostile environments in our solar system. They carry the hopes and ambitions of thousands of scientists and engineers, and indeed all of humanity. The journey of these rovers is an epic in its own right, a testament to human determination. Imagine the challenge to design a vehicle on Earth, launch it on a precise trajectory across millions of kilometers of empty space, and then land it safely on another world. The landing sequence alone is a nail-biting, choreographed ballet of heat shields, parachutes, and rocket-powered sky cranes. It is a feat so complex that it has been dubbed the 7 minutes of terror. Yet we have succeeded, delivering these incredible machines to their designated exploration sites, ready to begin their historic missions of discovery and science. Curiosity landed in 2012, a car-sized rover with a primary mission to determine if Mars ever had the right environmental conditions to support microbial life. It was sent to Gale Crater, a place where scientists believed the ancient history of Martian water might be preserved in layers of rock. For over a decade, Curiosity has been drilling into rocks, analyzing their chemical makeup, and sending back a treasure trove of data. It has climbed mountains and crossed dunes, painting a detailed picture of a world that was once much warmer and wetter. A world that was, in fact, habitable. Building on the incredible success of Curiosity, we sent its successor, Perseverance. Landing in 2021, this rover carried an even more ambitious set of goals. Its mission is not just to search for signs of past habitable environments, but to actively seek out signs of past microbial life itself. Furthermore, Perseverance is the first stage of an even grander plan. It is collecting and caching promising rock and soil samples, which a future mission will retrieve and return to Earth. These rovers are our proxies, our pioneers, and their journeys across the red dust are changing history with every turn of their wheels. At the very heart of our relentless drive to explore Mars lies one of the most profound questions humanity has ever asked. Are we alone in the universe? We know from our own planet that where there is liquid water, there is life. And the evidence overwhelmingly suggests that ancient Mars was a world of rivers, lakes, and perhaps even oceans. It had the essential ingredients for life as we know it: water, organic molecules, and energy sources. The question that burns within us is whether life ever took hold. Finding any evidence of life on Mars, even if it is just the fossilized remains of microscopic organisms, would be a discovery that would reshape our understanding of our place in the cosmos. This concept, known as a second genesis, would imply that the universe is likely teeming with life. The red dust of Mars, therefore, holds the tantalizing possibility of revealing that biology is a fundamental property of the universe. Exploring Mars furthers our knowledge of how planets work. Earth and Mars started as rocky siblings, but today they are worlds apart. Earth is a vibrant, watery oasis, while Mars is a cold, barren desert. Understanding why their paths diverged is a central goal of planetary science. Mars provides a crucial case study to understand the forces that shape rocky worlds, including our own. Studying Mars's geology tells us that Mars once had a thick atmosphere and a warmer climate. The leading theory is that Mars lost its magnetic field, allowing the solar wind to strip away its atmosphere. Unlocking this history provides vital clues about the long-term stability of planetary climates. Studying the climate collapse on Mars gives us a powerful perspective on our own climate crisis. Exploring Mars pushes the boundaries of science and technology, benefiting all of humanity. Beyond scientific questions, our exploration of Mars is driven by the desire to explore new frontiers. Mars represents the next logical destination. The dream of humans walking on Mars is a powerful motivator. Establishing a human presence on Mars is about securing the long-term future of our species. Becoming a multiplanetary species is the ultimate insurance policy. That ensures our survival and resilience in the vastness of the cosmos. The journey to Mars will require unprecedented levels of international cooperation and technological innovation. Ultimately, the dream of Mars is a dream for our children and grandchildren. The first human footprints on Mars will be a beacon of hope and achievement for all humankind. To search for past life on Mars, we needed more than a simple robot. We needed a true field geologist. Curiosity was born a car-sized rover, packed with advanced scientific instruments built to survive and explore for years. Its nuclear power source meant it could work through dust storms and freezing nights, unlike earlier solar-powered rovers. At the end of its robotic arm, a drill scoop brush, and high-resolution camera tools to dig, sample, and study Martian rocks up close. Inside, two labs, Shamin and Sam, analyze minerals and hunt for organic molecules, revealing Mars's watery and potentially habitable past. With this rolling laboratory, Curiosity could do what no rover had done before: act as a geochemist, reading the red planet's ancient story. Curiosity was ready to answer the question, was Mars ever a place where life could exist? With Curiosity built, the next challenge was the journey to Mars. Launched in November 2011 atop an Atlas V rocket, the spacecraft traveled over 560 million kilometers to reach its target, Gale crater. Protected inside a high-tech aeroshell, Curiosity's spacecraft made tiny course corrections, guided by engineers on Earth. Gale crater was chosen for its towering Mount Sharp, a mountain of layered rock, promising a record of Mars's environmental history. Landing there required unprecedented precision. The landing ellipse was smaller than ever attempted. As the spacecraft neared Mars, the landing sequence was uploaded. After that, Curiosity was on its own. With a 14-minute radio delay, the world could only wait and hope for a safe arrival. The descent to Mars was called 7 Minutes of Terror, a high-speed automated ballet of engineering. The spacecraft hit the atmosphere at 20,000 kilometers per h, its heat shield blazing at over 1,600 degrees Celsius. Guided entry then, a giant supersonic parachute slowed the craft, but not enough. The heat shield dropped away, radar locked on, and a rocket-powered descent stage took over. In a daring move, Curiosity was lowered on cables, the sky crane maneuver, since airbags couldn't handle its size. The rover touched down, cables cut, and the descent stage flew off to crash safely away. Every step had to work perfectly, with no help from Earth. For 7 minutes, the mission team could only listen to silence, waiting for a signal from another world. After a tense wait, a signal arrived. Curiosity had landed. The first image, a rover wheel on Martian gravel, with Gale crater's rim in the distance. Euphoria erupted at mission control. The 7 minutes of terror had ended in triumph. The landing site, Bradbury Landing, offered a geologist's paradise. Rocks exposed by the landing, ready for study. The first discovery cemented gravels, evidence of ancient, fast-flowing water. Curiosity's mission was clear: explore Gale crater, climb Mount Sharp, and uncover Mars's history. Each drive would reveal new clues about the planet's past. The adventure had just begun, but already Mars was giving up its secrets. Curiosity's first big find came quickly, in a spot called Yellowknife Bay. Drilling into mudstone, the rover found pale grey powder. Protected from Mars's harsh surface for eons, Shamin revealed clay minerals formed in neutral, drinkable water, ideal for life. Sam detected all the key elements for life: sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon. Billions of years ago, Curiosity sat on the bed of a calm, persistent lake. The evidence was clear. Ancient Mars had habitable environments with fresh water and essential elements. Curiosity's mission was a success. Mars was once a world where life could have thrived. The rover pressed on, piecing together the story of a lost watery world, more Earth-like than we ever imagined. Organic molecules, the building blocks of life, are key to finding a habitable environment. Curiosity's SAM instrument found simple organic molecules in 3 billion-year-old rocks. This confirms these building blocks were present on ancient Mars. Curiosity also detected methane in the Martian air, which on Earth is mostly produced by living organisms. The source of methane is a mystery. It could be geological or a sign of modern microbial life. This has transformed our view of Mars, suggesting a complex carbon cycle that could potentially support life. Curiosity has also been looking up at the sky, equipped with a weather station called REMS. This provides daily weather reports, measuring temperature, wind, pressure, and humidity, giving us a long-term climate record. One important discovery relates to radiation. Mars lacks a magnetic field and has a thin atmosphere. This radiation is a hazard for future human explorers. The rover has captured images of clouds, dust devils, and even watched the Martian moons transit across the sun. These observations bring Mars to life, transforming it into a dynamic living world. Curiosity has painted a rich portrait of Mars, revealing a planet that was once warm and wet. After a decade, Curiosity continues its climb up Mount Sharp, sending back data that deepens our understanding. The Curiosity rover proved ancient Mars was habitable, shifting our focus to whether life actually existed there. This required a new mission to search for biosignatures in ancient rocks. The Mars 2020 mission and the Perseverance rover were born. Perseverance builds upon Curiosity's design, but with new instruments to seek microbial fossils. Perseverance aims to characterize the geology and collect promising rock and soil samples for future return to Earth. Returning samples would allow scientists to analyze them with powerful instruments, potentially proving past life. NASA and the European Space Agency will launch a mission to retrieve these samples and send them back to Earth, a campaign that could finally answer, "Are we alone?" With a mission focused on finding signs of ancient life, the choice of landing site was critical. Perseverance would be sent to Jezero Crater, a 45-kilometer-wide impact basin that, billions of years ago, was home to a large, tranquil lake. What made Jezero so compelling was a beautifully preserved river delta fanning out across the crater floor. The delta in Jezero, clearly visible from orbit, was a geological beacon. Landing in Jezero, however, was an enormous challenge. It employed terrain-relative navigation. Perseverance executed its landing flawlessly. The first images sent back revealed a landscape that was breathtakingly beautiful and geologically fascinating. The stage was set for a historic exploration. To hunt for traces of ancient life, Perseverance has upgraded eyes and analytical tools. Unlike Curiosity, a mobile geochemistry lab, Perseverance is a robotic field astrobiologist. Its Mastcam Z camera surveys the landscape in high definition, spotting rock targets. Instruments like Sherlock, Watson, and Pixel map mineral and chemical distributions, seeking biosignatures. Perseverance's sample caching system extracts and seals rock cores in titanium tubes. Enhanced AutoNav allows it to map terrain and navigate autonomously, covering more ground efficiently. This makes Perseverance the most capable explorer ever sent to another world. As if landing a new, highly advanced rover was not ambitious enough, the Mars 2020 mission carried a passenger, a small experimental helicopter named Ingenuity. Tucked away on the belly of the Perseverance rover, this tiny 1.8-kilogram aircraft represented a high-risk, high-reward technology demonstration. Its goal was simple, yet audacious: to prove that powered, controlled flight was possible in the incredibly thin Martian atmosphere, which has less than 1% of the density of Earth's. Success was far from guaranteed. Many engineers believed it was impossible, as there is simply not enough air to generate lift in the same way a helicopter does on Earth. To achieve flight on Mars, Ingenuity had to be an engineering marvel of lightweight design and powerful performance. Its two carbon fiber rotor blades are much larger and spin much faster, over 2,500 revolutions per minute, than would be needed on Earth, all to bite into the thin Martian air. It is powered by solar panels that charge its lithium-ion batteries, providing enough energy for short flights of up to 90 seconds. The entire aircraft had to be autonomous, as the 20-minute round-trip communication delay makes real-time piloting impossible. It had to take off, fly a pre-programmed path, and land all on its own, surviving the frigid Martian nights in between flights. On the 19th of April, 2021, Ingenuity made history. It spun its blades, lifted off the surface, hovered for 30 seconds, and then landed safely back on the Martian dust. It was the first powered, controlled flight of an aircraft on another planet. This was our Wright brothers' moment on Mars, a stunning achievement that broke open a new dimension in planetary exploration. What began as a 30-day technology demonstration quickly turned into an extended operational mission. Ingenuity proved to be far more robust and capable than anyone had dreamed, becoming a valuable aerial scout for the Perseverance rover. Ingenuity went on to complete dozens of flights, covering kilometers of terrain and staying airborne for a total of over 2 hours. It provided a unique aerial perspective, scouting ahead for the rover to identify potential scientific targets and map out safe driving routes through hazardous terrain. It gave us breathtaking images of landscapes that the rover could never reach, such as rugged badlands and sandy dunes. Ingenuity's incredible success has proven the value of aerial exploration and has paved the way for future, more ambitious aerial missions to Mars and other worlds. It was a small drone that took a giant leap for planetary science. With Perseverance in Jezero Crater, its mission began. The rover first examined the crater floor rocks. Instruments revealed they were igneous, formed from cooling magma, reshaping the crater's geological story. Volcanic activity preceded the lake's formation. Dating these rocks will establish a timeline for the lake and climate change. Evidence showed water altered the rocks, creating potentially habitable environments. This investigation was the first chapter, establishing context for future discoveries. Perseverance collected core samples, preserving this early Martian history for Earth's laboratories. The Perseverance mission is the first leg of the Mars Sample Return campaign. The rover identifies compelling rocks and soils, drills core samples, and seals them in titanium tubes. We are preparing to bring Mars into our laboratories for analysis impossible on a rover. Perseverance created the first sample depot on another world, dropping 10 sealed sample tubes in a zigzag pattern as a backup. This depot is a collection of scientific treasure, holding clues to ancient life and planetary evolution. The samples are ready for their journey home. While Perseverance has been rewriting the geology books, its flying companion, Ingenuity, has been rewriting the rulebook for how we explore other worlds. What started as a 30-day technology demonstration has blossomed into one of the mission's most stunning successes. Ingenuity far exceeded all expectations, completing an incredible 72 flights over nearly 3 years. It evolved from a simple experiment into a vital operational partner, acting as an autonomous aerial scout. This little helicopter added a whole new dimension to the mission, proving that an eye in the sky is invaluable for ground-based exploration. Ingenuity's contribution to the mission was immense. It would fly ahead of the rover, scouting the path forward through treacherous terrain. Its aerial images allowed rover drivers to spot potential hazards like sand traps or sharp rocks and plan much safer and more efficient routes. This significantly sped up Perseverance's journey to the Delta and beyond. Ingenuity also provided a unique scientific perspective, capturing images of geological features inaccessible to the rover. It flew over sand ripples and up to the edges of steep cliffs, giving scientists a bird's-eye view of the landscape's large-scale structure in ways ground-level cameras never could. The flights were not just practical, they were also inspiring. The images it sent back were breathtaking, showing the rover as a tiny speck in Jezero Crater's vast landscape. We saw the helicopter's shadow as it flew over red dust, a sight that was once pure science fiction. Each successful flight built confidence and provided data on aircraft performance in Mars' thin atmosphere. This information is critical for designing next-generation planetary aerial vehicles, which could be larger drones or winged aircraft exploring vast regions in a fraction of the time. Ultimately, Ingenuity's mission ended in early 2024 after a rough landing damaged one of its rotor blades. But its legacy is secure. It proved the value of aerial exploration beyond all doubt. It gave us a new capability for seeing and understanding other worlds. The success of this helicopter ensures it won't be the last aircraft on Mars. Future missions will include advanced aerial explorers, thanks to the trail blazed by this remarkable machine. Ingenuity demonstrated that high-risk experiments can yield the greatest rewards. forever changing our perspective on exploration. Exploring Mars is one of the most difficult things humanity has ever attempted. The challenges are immense, starting with the sheer distance. Launching a spacecraft takes incredible power and precision. Once the spacecraft arrives, it faces the most dangerous part of the entire mission, landing. The Martian atmosphere is a cruel paradox. The Martian surface is an incredibly hostile environment. The atmosphere is unbreathable and offers little protection from radiation. A pleasant afternoon on the Martian equator might approach a mild 20 degrees Celsius, but at night, the temperature can plummet. Finally, there's the ever-present Martian dust, as fine as flour but as abrasive as sandpaper. Designing a rover is about building a survival machine capable of withstanding years of abuse. Every Mars mission presents enormous engineering challenges. Testing rovers in simulated Mars yards can never perfectly replicate the red planet. Engineers must build machines that are incredibly robust and adaptable. Rover wheels have to be designed to traverse a wide variety of terrains without getting stuck or damaged. The rovers must also be, to a large extent, autonomous because direct, real-time control is impossible. Operating a complex rover requires a lot of energy. Larger missions use a radioisotope thermoelectric generator, or RTG. Ultimately, there are no second chances. Every system must be designed with multiple layers of redundancy. This relentless pursuit of perfection makes building these explorers so incredibly difficult. We are living in a remarkable era of planetary exploration. Curiosity and perseverance are chapters in humanity's grandest scientific adventures. These robotic pioneers have transformed our relationship with Mars. Through their eyes, it's become a tangible world with a rich history. Curiosity proved Mars was once habitable, and perseverance is searching for signs of past life, collecting samples for future study. This provides a cautionary tale, giving us a deeper appreciation for Earth. These missions are a testament to our desire to explore and understand our place in the universe. Every discovery inspires millions and ignites curiosity in a new generation. The robotic exploration of Mars isn't an end in itself. It's a critical stepping stone towards an even bolder future. Every piece of data sent back by Curiosity and Perseverance helps pave the way for the day when we'll send not just robots, but humans to walk on the red planet. These rovers are our scouts, mapping the terrain, analyzing the hazards, and testing the technologies that will be needed for future human expeditions. Perseverance is even conducting experiments to produce oxygen from the thin Martian atmosphere, a vital capability for future astronauts who will need to breathe and make rocket fuel to return home. The dream of becoming a multiplanetary species is slowly but surely moving from the realm of science fiction to engineering reality. The challenges remain immense, from protecting astronauts from deep space radiation to developing sustainable life support systems for a long-term presence on a hostile world. Yet, the work being done today is laying the essential groundwork. The knowledge we gain from our robotic emissaries gives us the confidence to plan these audacious future missions. Mars is the next logical frontier for human expansion, a second outpost for humanity that could secure the long-term survival of our species. Looking ahead, the future of Mars exploration is brighter than ever. The Mars Sample Return mission, which will retrieve the samples collected by Perseverance, promises to be one of the most exciting scientific endeavors of the next decade. Beyond that, we can imagine fleets of more advanced rovers, squadrons of aerial drones, and eventually, a permanent scientific base where human geologists and biologists can conduct research in person. The journey will be long and difficult, requiring international collaboration and a sustained commitment over many generations. But it's a journey that we've already begun. The story of Mars is ultimately a story about ourselves. It reflects our relentless curiosity, our technical ingenuity, and our unyielding hope for the future. As we continue to unveil the secrets of this ancient, rusty world, we learn more about the nature of life, the evolution of planets, and the vast potential that lies before us. The tracks left by Curiosity and Perseverance in the red dust are more than just marks on another planet. They're the first faint footprints of humanity on a new shore, beckoning us toward a future where our destiny is written not just on one world, but among the stars.